talk about improper integrals. And if you're new to my channel, please make sure you hit the subscribe button and turn on the notification bell so that you don't miss out on any new videos. So to start off, there are two types of improper integrals. So for type 1, this is whereby the integrals where at least one of the limits is infinite, right? So for example, we're saying that the integral of 1 over x squared times the root of x with respect to x from 1 to infinity, right? We're saying that here the upper limit is infinite. And as well, for the second example, integral of 2 over x to the power 5 with respect to x from minus infinity to minus 2, we're saying that this is infinite, right? So we can define the integral of f of x with respect to x as from a to infinite as being equal to the limit, right, of the integral of f of x with respect to x from a to b as b approaches infinite, right? And then for the second one as well, we can define in relation to this example, we can define it as we can say the integral of f of x with respect to x, right, from minus infinity to b is equal to the limit, right, of the integral of f of x with respect to x from a to b as a approaches minus infinity. So these are only valid when the limits actually do exist, right? So this is for type 1. Now for type 2, we've got the integrals where the function to be integrated is not defined at a point in the interval of integration. So what do we mean by this? Right. For example, if we say the integral of 2 over x to the power 5 with respect to x from 0 to 1. Now let's try and substitute the limits. If we were to substitute for this lower limit, right, whatever that we get over 0, that becomes undefined. So this is what we mean when we say that the function to be integrated is not defined at a point in the interval of integration. So we can say the integral of f of x with respect to x from 0 to b is equal to the limit of the integral of f of x with respect to x from a to b as a approaches 0 plus. And a approaching 0 plus, what we mean is that we're saying that a tends to 0 from above. And this is when x is valid, right, between 0 and b, but undefined when x is equal to 0. So now let's see how we can apply what I've been talking about. Okay, so let's use this example. So for this example, we've got this improper integral, right? And we'd like to show that it has a value. And we want to calculate that finite value. Okay, so integral of 1 over x squared times root of x with respect to x from 1 to infinite. We're saying that this is also the same as integral from 1 to infinite of 1 over x to the power of half times x to the power of 2. We get x to the power of 5 over 2 with respect to x, which we can rewrite as from 1. Then now let's try and represent this infinite by a letter. Let's just choose a letter. Let's say b. Right. So from 1 to b, x to the power of minus 5 over 2 with respect to x. So integrating, now we integrate the normal way. So integrating the normal way, we're saying that we've got x to the power of minus 3 over 2 over minus 3 over 2 from 1 to b, which is the same as minus 2 over 3 x to the power of minus 3 over 2 with the limits from 1 to b. Now let's substitute for the limits. Substituting for the limits, we're saying that minus 2 over 3, right, b to the power of 3 over 2, right, minus lower limit minus 2 over 3, 1 to the power of 3 over 2. Right. But what do we know about b? We know that b is approaching infinite. So b is approaching infinite. But what happens when b approaches infinite? This whole term tends to approach 0, such that we've got 0 minus, then there we've got minus 2 over 3. Then we get a result of 2 over 3. So here we've shown that this improper integral has a value of 2 over 3. Now I'd like to attempt the following questions, just applying what we've been talking about. So allow me to erase this part. Okay, so for number one states that show that only one of the following improper integrals is a finite value and find that value. Okay, so for number part A, 1a, let's see what's happening with 1a. 1a, we've got the integral of 4 over root x from 0 to 1. So let's substitute the 0. Let's just choose any letter. Let's say a. Right. Or 4x to the power of minus half with respect to x. This would be 4 times x to the power of half over half from a to 1. And then now this would be the same as saying 8x to the power of half from a to 1. Then now substituting for the limits, we are saying that 8 times 1 to the power of half, that's just 8, then minus 8a to the power of half. Right. Then now we study what happens. Right. So now as a approaches 0, what's going to happen is a approaches 0, this 8a to the power of half also approaches 0. So we have 8 minus 0, which will give us an 8. So this first improper integral is a value of 8. Now the second one, let me do this in red. Now for the second one, right, we want to integrate with the limits from 1 to infinite. And then now let's substitute this infinite by, say, b, the letter b. And then we're going to say 4x to the power of minus half with respect to x. This, integrating the normal way, we still get 8x to the power of half with the limits from 1 to b. And substituting for the limits, we're saying 8b to the power of half minus 8. Right. But what do we know about b? We know that b approaches infinite. Right. So when b approaches infinite, what happens here? This whole term approaches infinite, and as a result, this will give us an infinite answer in such a way that it doesn't have a finite value. Right. So only one of the following has a finite value. So the one that is a finite value is this one. And then we've proven it here. This is for number 1. Now let's look at number 2. So for number 2, allow me to erase this part. Okay, so for number 2, for each of the following improper integrals, find the value of the integral and explain briefly why it does not have a value. So for the first one, this is for number 2a, right? So for number 2a, we've got the integral of x cube root of x, which is x to the power of 1 over 3, with respect to x, with the limits from 27 to infinite. So now let's substitute this, let's replace this infinite by the letter, let's say b, right? So integrating the normal way, we shall get 3 over 4 x to the power of 4 over 3, with the limits from 27 to to b. Now substituting the limits, we've got 3 over 4 b to the power of 4 over 3 minus 3 over 4 cube root of 27 raised to the power of 4. But we know that b approaches infinite. So when b approaches infinite, this whole term also approaches infinite. And the result will just be infinite, such that we don't have a finite value, right? So this does not have a value, the first one. So we can say does not have a value. Right, this is for the first one. And then for the second one, part B, we're saying that the integral, if we rewrite this, this would be 1 over, let's reduce it, 1 over x to the power of 4, right, raised to the power of 1 over 3, which we can reduce to 1 over x to the power of 4 over 3, and further on reduce it to x to the power of minus 4 over 3, right, overally. So we're saying that the integral of x to the power of minus 4 over 3, right, with respect to x, with the limits from 27 to infinite, let's say infinite, let it be the letter b, right, let's just represent it by the letter b, such that, integrating the normal way, we've got adding 1, right, we get a minus 1 over 3, so we're saying minus 3x to the power of minus 1 over 3 from 27 to b. Substituting the limits, we've got minus 3 over the cube root of b, then minus 3 over cube root of 27, right? But what do we know about b? We know that b is approaching infinite. So as b approaches infinite, what happens to this term? This term approaches 0 because the denominator just keeps on getting bigger and bigger. So this approaches 0, such that we've got 0, and then minus minus, that becomes a plus. 3 over the cube root of 27, that is a 3. 3 into 3, we get a 1. So this improper integral, it has a value of 1. Then we've just shown. So this was looking at improper integrals, and please feel free to leave a comment, drop a like, and don't forget to subscribe. Thank you.